Hey guys, so if you're watching this next part of the video series for the DCA 1 review, we're going to be working out the calculator active problems. The bad thing about DCAs in the exams a lot of times is that the problems on the calculator active, for example, 10 and 11, if you've already worked at these, you don't really need a calculator for. So the ones that we do need a calculator for, I've got a handheld calculator I'll show you how to do the problem on, and I've also got Desmos pulled up. But we're going to go ahead and work out probably one page at a time the calculator active problem. So y'all hang with me, make sure you're working these out as you watch this video. Again, just to check yourself and really make sure you're ready for the DCA tomorrow. So for number 7, the volume of a cylinder V equals the product. So the word product means we're going to multiply of pi, which for pi we know we use this symbol, the radius r, so we're multiplying by r, and the height h, so again we're multiplying by h. So we have volume equals the product of pi times r times h. Okay, so now we want to write an equation that expresses the radius in terms of volume, pi, and the height. So we want an equation for the radius, which means I want to solve this equation for r. Okay, so if I'm going to solve for r, then I'm going to cover up r, and I need to move the other terms on the same side as r so that I can get r by itself. So when I cover r, that means I need to move pi and I need to move h. So how do I move pi and h? By doing the opposite if they're multiplying. I can divide them. So if I divide by pi, those will cancel. And if I divide by h, those will cancel. And we're left with r. What you do to one side, you need to do to the other. So I've got r equals, on this side, v over pi h. So this is one where we couldn't use a calculator because this is a literal equation. There's no numbers. But you guys know how to set up an equation from a word problem, and you should know how to solve this for r by covering r and moving the other terms. So this is a very easy problem that we all should be getting right tomorrow, okay? All right, for number 8, given f of x equals 5x minus 1 and g of x equals 1/2 x plus 3, find f of 3. So in the f equation, I'm going to put in 3. So instead of an x, we're going to put in 3. So everywhere I see x, I am putting in 3. 5 times 3 minus 1. Plus g of 6. So in the g equation, they're putting in 6 for the input. So instead of an x, everywhere we see an x, we're going to put in a 6. So this is going to be 1/2 times 6 plus 3. Okay? So 5 times 3 is 15. 15 minus 1 is going to give us 14, right? Then for this equation, 1/2 of 6. So half of 6 is going to give me 3. And 3 plus 3 is going to give us 9. And then if we do 14 plus 9, we should be getting 23. So that's how you would evaluate f of 3 plus g of 6. We would put 3 into f and g in for the x in. Sorry guys, I don't know what happened to the video. So we're going to backtrack on this problem. So I was showing you guys how we could type this into the calculator. So we got 14 plus 6, which is 20. And I made an uh-oh and accidentally did 3 plus 3 is 9. So remember, make sure you just check your work. So one more time, we're going to check this in the calculator. So we put in 3 into the f equation, and we put in 6 into g. And I was showing you how you could type this in. So one more time, this is going to be 5 parenthesis, instead of an x, I'm putting in a 3, minus 1, plus, and then the g equation we talked about, 1/2 is a fraction, to type fractions in the calculator, you have to put them in parentheses. And then instead of an x for this one, I'm putting in 6 plus 3. And the calculator will spit out 20 to you. So no matter which way I do it, by hand or in the calculator, I'm going to get 20. Okay? Now the third way you could do this one, if you don't like having to substitute in 3 and substitute in 6, you could do this one in Desmos by graphing. Alright? So the third way I'm going to show you is in Desmos, my screen. And then for this one, if you go back and look at your review, we're looking for the value of 3. So when I go to where x is 3, that would be right here on the graph, I'm going to scroll up, and the y value is about 14. Does everybody see that? So for this first part, when you do it in Desmos, and you go look where x is 3, you do get 14. It looks like it's like right here by 14. Okay? Now, for the next part, if I go put in g of x equals 1/2 x plus 3, so g of x equals 1/2 x plus 3, and this time I'm looking for the value where x is 6. So I go look on my graph where x is 6, that's right here. Then when I go up, it looks like the value that goes with that is 6 on the y. So this 6 as well. So I'm doing 14 plus 6 in Desmos, which is also going to give me 20. So you have 3 different ways to do this problem tomorrow on the DCA. Any of the ways are great. I would do it by hand and then either use my calculator or use Desmos graphing to check. Okay? Now for number 9, this one's very similar. It says given f of x equals 3x minus 3, for what value of x? So we are trying to find x. They did not give us x. Would it equal 21? Okay? So do y'all see how they're saying f of x should be 21? I'm going to go put 21 in for f of x. And I'm going to solve this equation for x because it says what value of x. So first I'm going to draw my wall. Then I'm going to cover my x. I need to move a -3 by adding it. What you do to one side, you do to the other. So this is 24 equals 3x. And now if I divide the 3, you get x equals 8. So the answer should be 8. Now I'm going to show you guys how we can use Desmos to check this, okay? So if you go to Desmos and you put in this equation and you also put in this equation, then we should see a spot where those two lines overlap, okay? So let's go look at it. I'm going to type in f of x equals 3x minus 3. And I'm also going to type in f of x equals 21. Okay? I'm going to zoom out so I can see where they overlap. Wrong one. Alright, and if you look, this is f of x equals 21, the red one. And then this is f of x equals 3x minus 3, the black one. And they overlap at the point 821. So this point right here, 821. So if you go look at the question, it says what value of x. So if we look at our graph, the x value of this overlap point is 8. So again, no matter which way you do this one, you should get an x value of 8. Okay? Alright, so next up on the review, these next two problems you do not need a calculator for. Every year I have students ask me why they give y'all these on the calculator, because these could really be on the non-calculator. And I think the reason why they do it is because they like to put problems where you have to actually do math on the non-calculator. So for these two, yes, we have to look at a graph and we're matching the right number for the answer choices, but there's no actual math calculations. You're not having to add or subtract or anything. So if we look at number 10, it says the scatter plot below shows the bone mineral, blah, blah, blah. Which of these would be a reasonable correlation coefficient? So remember, your correlation coefficient is your R value from 0 to 1. And I think every teacher has taught the McDonald's method. Yes, it's corny, but you guys usually remember it really well. So remember, this has to be strong because it's close to $1. If you go to McDonald's and you have $1, they used to have the dollar menu. If you had between 50 and 75 cents, You used to at least be able to get like a hash brown or an apple pie, so that's moderate. 25 cent to 50 cent, all you can get is like a cup of ice or a cup of water, so that's weak. And then if you have less than a quarter, you can't get anything from there. So if we look at this graph, these scattered points, so these ordered pairs, these data points, they look kind of spread apart, but they don't look super duper weak, because if I try to draw a line through them, it looks like a lot of them are really tight to that line, right? So the first thing you should notice about these points is that they are going down. So remember, we read our graph from left to right. So from the left down to the right, they are going down, which means this is a negative correlation. So I'm marking out A and B because those points are not rising. This is not positive. So now between C and D, I have to decide, does it look pretty strong or does it look really weak? Because 25 cent is right on the border of weak and no correlation. Now, we just talked about how a lot of these points are really tight to the line. So I would definitely say that this is stronger, okay? Now, on your DCA tomorrow, I'm going to give some of y'all some hints if you're watching this far. The one on the DCA tomorrow, the answer choices are a strong one or a moderate one. So if you look at this graph, I would actually say this is more moderate because they're a little more spread out. So on the DCA tomorrow, if you have the option of like 0.9 and 0.7 for this one, I would definitely say it's closer to 0.7, and these should both be negative, okay? All right, number 11, also no calculations needed, so let's read it. Noah is pouring water from a bucket into a barrel. The correlation coefficient is negative 0.98. So we're looking at this correlation coefficient right here. So a couple of things we know. If it's negative, that means that what? So that means that the water in the barrel should be increasing, but what is the water in Noah's bucket going to do? Water in bucket should be going down, right? So we need to look for the answer choice that says that as the water in the barrel is going up, the water in Noah's bucket is going down. So remember, the water in the barrel is always going to go up because when we make a graph for our x's, the smallest number always starts here and the biggest number always goes down here. So our x's are always going to increase, but these y's are decreasing. So I want to look for the answer choice that says the water in the bucket, or excuse me, the water in the barrel goes up and the water in Noah's bucket should go down. So let's see. Water in Noah's bucket increases? Nope. Water in Noah's bucket decreases. Water in the barrel increases. That looks good. Let's see. Water in Noah's bucket increases? Nope. Water in Noah's bucket decreases. Water in the barrel increases. Good. So now between B and D, 0.98, is that strong or weak? That should be a strong relationship, so I'm going to pick